Okay, everybody, I'd like to talk about vectors, which is actually from chapter 8.6 in our textbook. We're kind of going backwards a little bit, and we're going to have 2 days of notes. This is our day 1 notes about vectors. All right, first of all, definition of a vector. A vector is a line segment that has length and direction, okay? So we need to take both into account, the length and the direction of a vector, okay? The notation, for instance, if I have a vector that has an initial point of A and a terminal point of B, the notation is you usually have a lowercase letter with a little vector above it, okay? It can be a little arrow if you want, almost like a ray. You can write it in component form. Component form looks like this. The brackets are pointed like this, and you have an X and a Y value. This is your horizontal change. This is your vertical change. So if it's on a grid, it's how far over you go is your X value, how far up you go is your Y value, almost like you're calculating the slope. All right, so let's talk about length and direction separately. Length. Length is called magnitude. Okay? And it's found with the Pythagorean theorem and the distance formula. For instance, you could write this calculation. The magnitude equals the square root of the change in x. I'm using the change notation, this delta symbol here. It's the Greek letter delta, and it means change. It's the change in x squared plus the change in y squared. And you should recognize that as the Pythagorean theorem. So it's this x distance, square it, this y distance, square it. Take the square root of it will be the magnitude or the length of your vector. In physics, you'll often see this as some sort of force, some speed, etc. will often be represented by the length of the vector. All right, let's talk about the direction of the vectors. Okay, it's measured counterclockwise from the horizontal, just like degrees. So I'm measuring that direction for the angle that I'm going to have counterclockwise off of the horizontal. So what you can imagine is, draw a bigger circle here. Okay, if I've got a vector like this, I'm measuring from the horizontal. I'm trying to find this angle right here. I have an x distance and a y distance. You can see that the tangent of my angle, alpha, is going to be y over x, opposite over adjacent, okay? So my angle is the inverse tangent of y over x. And you can get those y over x values from up here. So you can calculate magnitude from these x, y values in the component form, and I can find the angle from these x, y values in my component form. Okay? Very quickly, direction can also be given less mathematically in the form of a bearing. And you just kind of have to convert it as a bearing. And you'll hear that anything that involves piloting, boating, those kinds of things. So frequently you'll hear a bearing like this, north 30 degrees east. What that means is, as you're looking north, it's 30 degrees towards the east. Okay, this is north, this is east. So north 30 east is the same thing that we call 60 degrees. That being 60 right there. Okay, so you might need to convert a bearing, and they're usually sandwiched, but I think they'd have to be sandwiched in between two directions like that. Okay, so it's off of north, you go 30 degrees towards the east. Okay, so we're going to practice this in class tomorrow. We're going to do some problems out of the book using all of this. The things you need to know for tomorrow or for the next day we're in class is that vectors are measured, or they have a length and a direction both. They're represented in component form by their horizontal change and their vertical change. You can calculate their length or their magnitude using the Pythagorean theorem with that x and y values. You can find their direction using the tangent function as an angle, as we've always measured angles. And lastly, you can discuss vectors as bearings because it's often used in piloting and boating and things like that. Just have to remember how to convert them. Thank you very much.